Okay, worksheet 7.4. Now, you did this a lot in Algebra 2 last year, so hopefully we'll be able to go through it fairly quickly here. It's just factoring and finding zeros because it's a big deal when we get to graphing. So when we're factoring a funky polynomial like this, we're going to say, okay, oh man, I got to factor it. It's all funky. I got to try to figure it out. So we're going to do that good old P over Q that we used to do back in Algebra 2, where P are the factors of the constant term and Q are the factors of the lead coefficient. So you'd say, okay, these are my possible rational zeros, my possible rational roots. So I have to do P over Q. So I'd say, well, -1. So -1 could be plus or minus 1. And then -1 down here could be plus or minus 1. You're saying this is a pretty stupid example because 1 over -1, 1. So my only possibilities here are 1 and -1. My only possibilities are 1 and -1. So yeah, I agree. It's kind of an easy example. Just for the record, then somebody yells at me and says, well, why do we always have to start out doing P over Q? Oh, and by the way, we're not going to make you list all the list of P over Qs like you had to do in Algebra 2. You're just going to have to kind of know that. Just for the record, somebody says, well, I don't want to start with P over Q. I want to do my own thing. I want to start with a 2. Well, 2 is not one of your possible zeros, so you know 2 is not going to work. That's why I'm doing this. So let's see what happens if I try something that's not on my list. It's not even on my list. And what do you know? It didn't work because I got a remainder. So we know that 2 didn't work. Okay. So over here, we're going to say, all right, who do you want to start with, 1 or -1? So I would, whatever, start with 1. Who cares? We're going to find out if it works or not. So bring down the -1, -1, -1, -2, -2, 0. 1 times 0 is 0. 2, 1 times 2 is 2. 1, 1, 0. Hey, far out. It works. So 1 is definitely a 0. So I started with x to the 5th. Now I'm at x to the 4th. So we're going to say, all right, we got to keep going. Let's try -1. 1 worked. Let's try -1. So we bring down the -1, blah, blah. That makes -1, -1, and that makes 1. That makes -1. -1 times 1 is -1. Oh, what do you know? That worked also. So, hey, check it out. Now I've got this. And you're thinking, wait a second. I started x to the 5th. This row is x to the 4th. This row is x to the 3rd. You could actually factor this by grouping now if you wanted. If you wanted to, you could factor this by grouping. Or, like Dora the Explorer says, you could keep going. I don't know. Let's try 1 again. Let's see if 1 works again. 1, -1, 1, blah, blah, -1, -2, -2, -1, 1 times -1. Oh, what do you know? That worked also. So 1 is repeated already. So that means 1 has a multiplicity. It's repeated more than once. Now, if you wanted to, see x to the 5th, x to the 4th, x to the 3rd, this is x squared now. See, now you've got -x squared minus 2x minus 1 equals 0. You could actually factor this the old-fashioned way. If you wanted to, you could factor this the old-fashioned way. Factor out the negative. So plus 2x plus 1. So, oh, what do you know? That just factors 2x plus 1, x plus 1, which would mean the zeros would be -1 and -1. So if you wanted to, now you could say, look, I've got a 1 and 1, -1, -1, -1. If you wanted to do that, once you got to this step of x squared and factored it the old-fashioned way, or like I said, this would have factored by grouping, x cubed, -x cubed minus x squared plus x plus 1, that would have factored by grouping. Just for the record, let's do this. We know that -1, -1 are going to finish it off. So I do -1. So 1, -1, 1, 0. So I know that -1 is going to finish it off. So -1, 1, 0. Hey, check it out. X to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, no more x. No more x. But one critically important thing, there's still that negative out front. That negative out front means there's still going to be a negative out front when we do our factors. And you're thinking, well, that seems logical because we had a negative in front of our lead coefficient. So now let's do our factors. Okay, so we got X, we got X. Well, check it out. Our zeros are 1 and -1. So that means we're going to have X minus 1 and we're going to have X plus 1. Well, -1 was repeated 3 times. -1 was repeated 3 times, which means we're going to have X plus 1 cubed. +1 was repeated twice, so we're going to have X minus 1 squared. +1 was twice, so X minus 1 is squared, which means our zeros are -1, but it was repeated 3 times. So we say multiplicity 3. 1 was repeated twice, so we just say 1, and I'm going to abbreviate from now on multiplicity 2 like that. Okay, so here's our factors, here's our zeros. Not too big of a deal, right? And you did this, I mean, this is review. I know some of y'all hated this from last year, but this review. All right, let's do a slightly more complicated. And actually, this is not a more complicated example because it's just an X cubed. But I wanted to do something that had a slightly different P over Q. You're going to say, my P over Q, my factors of 7. See, my P over Q, my factors of 7 could be 1 or 7. And then my factors of 1 would just be 1. So my possible rational roots would be 1 over 1 or 7 over 1. So I could have 1 over 1 or 7 over 1. So everybody jumps up and down and says, okay, well, I'm contrary. So I'm going to try -7 first, which I would not recommend. I would never start with the big numbers. Always start with the small numbers. I'm going to try -7. What the heck? So 1, -7, -12. What is that? 84. What is that? 71. What the what? Or whatever. It's way too big. So I'm not even going to multiply that out. What is that? -497. So -504, whatever. It's definitely not 0. So you're thinking, okay, -7 didn't work. So we never have to try -7 again. We can eliminate it. Somebody else says, okay, well, I'm going to try +1. That didn't work. And then you're thinking, yeah, from now on, I'll just start with a small number. So I'm going to try +1. So 1, -4, -4, wait a second. +1 didn't work either. What a bummer. So maybe we should try -1. All right, let's try -1. So if I try -1, so I'm trying -1, and what do you know? -1 worked. So, and then like I said, we started with X to the 3rd. Now we're at X to the 2nd. If we wanted to, we could factor if we wanted to, we could factor this the old-fashioned way now. Once I get to an X to the 2nd, because you did this all the time in Algebra 1. So X to the 3rd, so this row is X to the 2nd. So if you wanted to, you could go to the old-fashioned factoring like that and say, therefore, X is equal to 7, X is equal to -1. So what do you know? I have -1 twice now. But let's, just for the heck of it, prove this. So, all right, why don't we try 7? So if I do 1, 7, 1, 7, 0. Oh, so 7 did work, remainder was 0. Now I think -1 should work again, -1. And by the way, the order doesn't matter. We could do this in whichever order you want. Oh, what do you know? -1 worked also. So this row, X to the 3rd, X to the 2nd, X to the 1st, no more X. And it's positive in front, so I don't have to worry about a negative in front. So let me see, I've got -1 twice. So -1 multiplicity, and then I've got 7 once. So -1 makes X plus 1 squared because it's multiplicity 2, and 7 makes X minus 7, and it's only 1 time. So we just leave it like that. So a little bit more complicated. These definitely take some trial and error. This takes some trial and error, and I know that frustrates people, but we can do it. Just a little trial and error. You can do it.